Hi everyone, I am Vanita. I am doing BE in Electronics and Communication Engineering in SVCE Bangalore. I am from Honda section. Today my subject is chemistry. In that my topic is nanomaterials. Let us see about the introduction. A nanomaterial refers to a material with at least one of its dimension in nanoscale. Size of nanomaterials varies from a nanometer to 100 nanometers. A nanometer is 1 billionth of a meter, that is 10 to 9 meter. A nanometer is approximately the length equivalent to 10 hydrogen or 5 silicon atom aligned in a line. Nanotechnology has become a interdisciplinary science involving chemistry, physics, material science, biology, and medicine. Nanotechnology is the study of all the phenomena and process involved in the synthesis, properties, and applications of nanostructures and nanomaterials. Any nanomaterials of nano size with its property is distinctively different from its bulk from are considered as nanomaterials. Every nanomaterials has three-dimensional structures of nano size. They are classified into 0, 1 and 2-dimensional materials. Nanoparticles, nanoclusters and nanocrystals are called zero size dimensional. Nanorods, nanowires, nanotubes are one-dimensional and nanofilms are two-dimensional. The invention of scanning tunneling microscopy (STM), atomic force microscopy (AFM), transmission electron microscopy (TEM) helps in new possibilities for the characterization, measurement, manipulation of nanostructures and nanomaterials. Size dependent properties of nanomaterials. Nanomaterials exhibit several size dependent properties like surface area. Many physical and chemical properties of a material depends on its surface properties. If a bulk material is subdivided into individual nanomaterials, the total volume remains the same, but the collective surface area is greatly increased. For example, the collective surface area of cube, each side of 1 meter is 6 meters square. If this cube is progressively cut into smaller and smaller cubes, the surface area will increase to 6000 kilometers square. Thus, surface area is enormously increased on moving from bulk to nanoscale. Properties like catalytic activity, gas absorption, and chemical reactivity depends on the surface area. Therefore, nanomaterials can show absorption in bulk materials. For example, bulk gold is catalytically inactive, but gold nanoparticles are catalytically very active for selective redox reaction. Catalytic properties. The catalytic property of materials depends on particle size. If the size of the particles reduces from bulk to nanoscale, surface area increases. That leads to very high catalytic activity of the same material. For example, bulk gold is catalytically inactive, but gold nanoparticles are catalytically very active for selective redox reaction. Let us see about the conducting properties. Nanomaterial shows different conducting properties like electrical conductivity, thermal conductivity, photoactivity, etc. Let us see about the electrical conductivity. The electrical bands in bulk materials are continuous due to overlapping of orbitals of billions of atoms. But in nanoparticles, very few atoms or molecules are present, so the electric bands become separate, and the separation between different electric state varies with the size of the nanomaterials. Hence, some metals which are good conductor in bulk become semiconductors and insulators as their size is decreased to nano levels. B. Thermal conductivity. As the size of the material decreases to nanoscale, their melting point decreases because surface atoms are in contact with only few atoms in nanomaterials and require lesser energy to overcome intermolecular forces. For example, 3Nm cadmium selenide nanocrystal melts at 700 Kelvin compared to bulk cadmium selenide at 1678 Kelvin. Synthesis of nanoparticles, bottom up approach. There are many techniques available to synthesize nanomaterials which can be generally grouped as top down and bottom up approaches. In top down approaches, bigger materials are broken down into small nano-sized materials by means of various physical methods. But these approaches has limitations like this method requires expensive apparatives, these methods causes crystallographic damage and introduce surface defects and internal stress in the resulting nanomaterials. Nanomaterials obtained from these methods are generally contaminated. In bottom-up approach, desired nanomaterials are built from the bottom by orderly assemble of growth species like atoms, molecules, ions. This approach has advantage like the methods are simple, versatile, and economically viable. Method provided provided better control over chemical composition, size, microorganisms, and aspect ratio of the nanomaterials. Nanomaterials with less defects and high purity were synthesized. Advantages: nanoparticles of high purity and good homogeneity can be obtained. Easy to control synthesis parameters to control physical characteristics like shape and size of resulting materials. Limitation: it's difficult to control the growth of the particle. Co-precipitation method. Precipitation process involves two steps: nucleation and the growth of the particle. Precursors used in this method are the hydrolysis products of metal salt, usually nitrate or acetate of metal. When a precipitating agent like NaOH, NH4OH, or Na2CO3 is added to precursor solution, it changes the pH and causes condensation of precursors, and it also introduces additional ions into the system. Thus, concentration of solution increases and reaches a critical level called a supersaturation. At this concentration, nucleus formation is initiated. A nucleus further grows into particles which gets precipitated. The product obtained is filtered, washed with water, air dried, and finally calcinated at higher temperature to remove anions of metals, salts like nitrate or acetate, which are readily decomposed. Precipitation synthesis can be used to prepare nanoparticles of metal oxides and metal sulfides. Thank you for watching.